Hello. Today we will study part 2 of chapter 15, hypothesis test and confidence intervals related to multiple regression model. Let us first review the population model. The population model had the form y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus all the way to beta p xp plus epsilon. Now we take the expected value of y to get rid of this epsilon. In this case, the equation will be expected value of y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus all the way to beta p xp to establish a significant relationship between x1 all the way to xp and y, where beta 0, beta 1, all the way to beta p are the population parameters. Moreover, beta 0 is the y-intercept, beta I equals to 1, all the way to p is the slope, and epsilon is the random error in y assumed to be normally distributed with expected value of epsilon is 0 and variance of epsilon is sigma squared. Now here's an example of this epsilon term that we have this expected value of epsilon is 0, so you have no pattern. And for this example, and we have this non-constant variance associated with this epsilon, and the condition of variance is constant is violated. And note, epsilon is the error term for the population model, and E equal to y minus y hat is the residual between y and x1 all the way to sp on average, and this E is the sample is from the sample model, and it's also an error term. Now let's consider the hypothesis testing. Similar to the simple linear regression model, we use the t-test for testing the true slope. In this chapter, we are going to use this t-test for the true slope beta I for I equals to 1 all the way to p. To determine the existence of a significant linear relationship between the xi and y variables, a hypothesis testing of whether beta I is equals to 0 or not is used. So step number 1, we will state h0 versus h1. In this case, h1 is beta I not equal to 0 to establish a significant linear relationship between xi and y versus h0 beta I equals to 0. Step number 2, we will compute the test statistic, and the test statistics is using this equation 15.15, and this t-cal is equal to bi over sbi with n minus p minus 1 degrees of freedom, and p is the number of independent variables. Note, just what I have mentioned. P is the number of independent variables or number of x's. Bi is the slope of the variable xi, and SBI is the standard error of the slope bi. And then step number 3, we will make a decision using either the p-value approach or the critical value approach. Now, for the p-value approach, we reject a 0 if this p-value is less than or equals to alpha. For the critical value approach, keep in mind the test is a two-tailed test. So the critical value is equal to t sub alpha over 2 with degrees of freedoms of n minus p minus 1. And for the critical value approach, we reject a 0 if the test statistic is less than or equal to the critical value on the left, or the test statistic is greater than or equal to the critical value on the right. And here's the rejection region. And we are going to reject a 0 if the test statistic is greater than the critical value on the right or less than the critical value on the left. And if it's in between, then we fail to reject as 0. Note, here is the important statement. If we reject a 0, then the corresponding independent variable is significant in explaining why and should be included in the model. Otherwise, it should not be included in the model. This is a very, very important statement about the hypothesis testing. Now, let's study the confidence interval. The 101 minus alpha percent confidence interval for the true slope beta I is given by this equation. You again have the point estimate plus or minus the margin of error. So we have bi plus minus t of alpha over 2 times SBI with n minus p minus 1 degrees of freedom. Now, let's look at this example. Example number 2. The firm wants to predict the sales, this is Y, in the unit 1000. Using the market value X1 unit in 1000, the total access S2 unit in 1000, and the number of employees, that's X3. To do so, 34 firms were randomly selected, and we enter the data into the Excel worksheet and obtain the following Excel output. You have this Excel output, and you have intercept, market value, total access, number of employees, and the coefficients are 147.39, that's our B0, and 0.0737, that's our B1, 1.0166, that's our B2, 0.0113, that's our B3. Now, here's the standard error. We have 100.676, that's our SB0, 0.117, that's our SB1, 0.163, that's our B2, 0.011, that's our B3. And t-test, that's our test statistics, for the intercept is 1.464, for the market value is 0.628, for the total excess is 6.220, for the number of employees is 1.074, and the p-value for the intercept is 0.0171, and for the market value is 0.543, for the total excess is 5.9 times 10 to the negative 5, and for the number of employees is 0.307. Now, we need to answer some questions. Question number 1. If the firm wants to test whether the coefficient on market value is significant, what is the relevant test statistic and what decision should be made? In here, we need to use the critical value approach to solve the problem with alpha equals to 0.05. So step number 1, we will state H0 versus H1. And H1 is beta 1 not equals to 0 versus H0, beta 1 is 0. So we need to use the critical value method, and the degrees of freedom is n minus p minus 1. We have 34 observations. So you have 34 minus 3. P is the number of x's, which is 3, and minus 1, and we get the degrees of freedom will be 30. And the critical values plus or minus t of alpha over 2. Alpha is 0.05, alpha over 2 is 0.025. So use the t-table, we actually get the critical value to be plus or minus 2.0423. So we draw this number line, put the 0 in the middle, and our critical value will be 2.0423 and negative 2.0423. Now our t-cal, or the test statistic from the table, is 0.628, which is less than the critical value on the right, so we failed to reject a 0. Now, here is the concluding statement. We failed to reject H0. There is not enough evidence to conclude that beta 1 is different from 0. So, the market value is not significant in explaining the cells, should not be included in the model. Question number 2. If the firm wants to test whether the coefficient on total excess is significant, what is the p-value? What decision should be made? Use the p-value approach to solve the problem with alpha equals to 0.05. So step number 1, we state H0, H1. H1, beta 2 not equals to 0 versus beta 2 equals to 0. Now, the p-value is 0.00059 from the table, and this value is less than alpha, 0.05, and we reject as 0. Again, here's the concluding statement, or we call it concluding remark. There is enough evidence to conclude that beta 2 is different from 0. The total excess is significant in explaining the cells and should be included in the model. Question 3. Find the 95% confidence interval for the true slope of the number of employees. So this is beta 3. And now from the table, we get B3 to be 0.0113 and SB3 is 0.011. And the critical value T's of alpha over 2 is T's of 0.025. Again, the degrees of freedom is 30, and using the T table, we will be able to find this critical value to be 2.0423. So using our equation for the confidence interval, we have the point estimate B3 plus minus the critical value times SB3, and this is the margin of error. So we have 0.0113 plus or minus 2.0423 times 0.011, and our lower limit will be 0.0113 minus 2.0423 times 0.011, and we ended up getting this lower limit to be negative 0.011, and the upper limit will be 0.034. Note, there is a relationship between the confidence interval and the hypothesis testing. For the same alpha, if the confidence interval includes 0, then we fail to reject F0. Here is the last topic for the multiple regression model. Which multiple regression model to choose? You see, after the hypothesis testing, we get rid of some independent variables that are not significant, and then we will use the data to find the multiple regression model associated with our new model. And we wanted to know which multiple regression model to choose. And we consider two important criteria. Number one, the multiple coefficient of determination should be close to 1. Number two, the standard error of estimate should be small. So let's go back to this example number 2. When we predict the cells from 3 independent variables, access, market value, and number of employees, and we get a model. And now, after we get rid of, say, the number of employees, and we obtain another model. So we have this model number 1, cells is equal to 147.40 plus 1.02 times the total access plus 0.01 times the number of employees plus 0.07 times the market value. In this case, the multiple coefficient of determination is 0.97 and the standard error of estimate is 263.31. And after we get rid of the number of employees and we use the data to obtain a new model, which is model number 2. And in this case, sales is equal to 187.18 plus 1.05 times the total access plus 0.06 times the market value. And the multiple coefficient of determination in this case is 0.99 and the standard error of the estimate is 212.87, and compare with those two criteria, we will pick model number 2. And this is the end of chapter 15.